think we're gonna, what I'm gonna do, I wanna do problem 3-2.4 and then get into section 3.3 and then finally, we'll do the covariance, or really, the correlation, it's the covariance matrix information. Let me see here. All right, so let me give this to you. I want to do this section in this book. I'm going to be jumping back to the other book shortly. Well, I want to finish this, the joint probability stuff here, but we will jump back. So 3-2.4. And the only thing I'm trying to do is apply the theory to problems, because that's, in my opinion, the single best way to learn this stuff, is actually apply it to problems. Just putting out theory, unless it's applied, oftentimes doesn't mean a lot to you. So for this one, so it's 3-2.4. Go ahead.
Okay, so you have a random signal X can be observed only in the presence of independent additive noise.
All right, so now we're going to talk about Y equals noise plus signal. And Y is the observed value. You all with me, class? We talked about this one, remember? I want to make sure everybody follows me. Go ahead.
And then it says the joint probability density function of X and Y is K.
F of X comma Y. Okay, go ahead.
Exponential negative parentheses X squared plus Y squared plus 4XY.
Plus 4XY
Yes,
over sigma? Or is it just that?
it's just that.
Okay, and this is for what values of X, Y?
All X and Y.
For all?
All X
Okay.
and Y.
All right. And what's the other part?
The question is, find a general expression for the best estimate of X as a function of the observation capital Y equals Y.
All right, so they're going to say we observe Y. So Y equals something, and it doesn't matter what you call it. I'll just call it Y equals A, and they want to know the density function, or they want to know the most probable value for X, right? Did they want to know K in this one?
They don't want to know K. It's just find a general expression for the best estimate. I guess finding a general expression would be finding K.
You can, but I mean, out of curiosity, how do you find K in general? Remember, this is a joint density, and it's valid for x, y from minus infinity to plus infinity. How do you always get K? If you got any constants inside the density. That's a joint density function, right? If you integrate that over where the actual values x and y can exist, it has to be 1. So the first step, A, at least I would write down, and even though if he didn't say it explicitly, is 1 is equal to, and I can take K out in front, okay, and it's going to be a double integral, right? And it's, well, yeah, of e to the minus quantity x squared, and then you would have e to the minus y squared, and then you would have e to the minus 4xy. I guess I'm not going to be able to break that anytime soon into two parts, dx dy. And here, x would go from minus infinity to infinity. Y would go from minus infinity to infinity. Now that would be the way you would get k. And I was looking for a quick way to do this. If it was just x, if that was a minus 2xy, you could factor it easily. But the way it stands, you can't. Anyway, this is how you would get k. I'm just going to put this down here. He didn't ask for k. And let me give you the solutions manual. Here, I put the solutions up there. I'll give you this. Can you take a look at this one? If they want k, we can get it. We can do this integral. Let's see, that is, it's actually a bit tricky. The x integration is a bit tricky. But anyway, if we want the most probable value, right, of that, now I'm going to say this. Pardon me?
He wants the expression for the best estimate of x,
Right,
as a function of the observation y equals
So he
y.
wants f of x f of x given y, and that's equal to, one of them is f of x comma y over fy of y, right? That's 1. So if we're going to do that, how do you get f of y? You have to integrate this, right?
Oh,
Don't you?
with respect
And you have
to
to
x.
integrate with respect to x. So we can say that Here, fy of y equal, but I'm gonna do something a little bit sneaky. It's gonna be equal to the integral from minus infinity to infinity of k. For this case, the k's are gonna cancel, and it's gonna be e to the minus quantity x squared plus y squared plus 4xy. And this is going to be dx. Now this would be f of y. You'll notice it's only going to be a function of y. That's the key point of this. Y'all with me on this? This is only going to be a function of y. So I can write this as, and I'm going to leave it as just a function of y. Just call it f y of y. This will become unnecessary because it's not a function of x. And it's times the joint one, exp to the minus quantity x squared plus y squared plus 4xy. So that's the f of x given y. Now, this is one thing I was trying to make the point of on the Zoom stuff. If you look at this by itself, if we're trying to find the best estimate, we want to take the derivative of f of x given y with respect to x, set it equal to 0. And the value of x that would give us that would be the correct value, the best estimate. Do you all follow me on that, class? I mean, this function, if we actually graphed it, I don't know exactly what it's going to look like, but there's going to be something where it has, depending on the value of y, it's going to have something like this. And if this is x, right there is our best estimate of x. It's where f of x given y is a peak. Y'all with me? Now, the nice thing about these exponentials is when this argument right there inside the exponential goes to 0, that's the maximum value. Do you all agree with me on that, class? We could do the derivative and set it equal to 0 and stuff like this. But if that's the case, if we have x squared plus y squared plus 4xy equals 0. Remember here, y is known, right? So I can say if y is known, I have really minus y squared is equal to x times x squared, and then it's going to be plus 4y. You can do it this way. You could do it what? You can just factor that, right? Since y, I'll put it as y equals a here. And here I have x squared plus a squared plus 4xy equals 0. Well, y is, sorry, I should have done it differently. I should have done this. X squared, and it would be plus 4xa, and then it would be plus a squared equals 0. Here I'm saying a is equal to y, or y is equal to a. And this is going to be, the roots of this, x equals will be minus b, so it's minus a squared, plus or minus square root of b squared, minus 4ac, oh, I'm sorry, minus this is b in this equation, so it would be minus 4a plus or minus the square root of b squared minus 4a is 1, c is a squared, all over 2. Do you all follow me? I'm just doing the quadratic on that. You agree with this, class? And I used a there just so I wouldn't confuse anybody. I'm just putting a constant there. Are you with me on this? So what's this going to be? Well, that's x equal minus 4a, and this is plus or minus the square root. Well, this is going to be 16a squared minus 4a squared, right? So that's 12a squared over 2, and what is that? Minus 2a plus or minus the square root, and take 4 inside there. So it's really square root of 3 times a should be the solution for the roots of that. Is that right? I mean, you got the solutions manual. And I can put in y in here. Actually, let me do it this way. X would be equal to minus 2y plus or minus the square root of 3, square root of 3y. And you could factor that a lot, but that's what about. Does he have that? Does he give a value? He doesn't give a value for one. I did all these last night. Hold on, did I? I don't think I copied anything there. We can do that, but I guess I take it back, because y can have negative values, but still setting it equal to 0 should be the right way to do it. Let me go ahead and just do the derivative of it. I did this last night, so if we come down here, we only care about this function. We want to know where it's a maximum. So if we take a look at the f of x given y equal to this e to the minus x squared plus y squared plus 4xy over f of y, if you go ahead and take the derivative of that and set it equal to 0, this f of y down here doesn't matter because it's going to just go away. So I'm taking a derivative with respect to x of the quantity e to the minus x squared plus y squared plus 4xy. I take a derivative of that. All right, so it's going to be the exponential e to the minus x squared plus y squared plus 4xy. And then when I take a derivative of the inside, I get minus 2x right here plus, minus. It's going to be a minus because there's a minus in front. So it's that minus 4y. All this equals 0. So minus 2x minus 4y equals 0 is going to be 2y is equal to x. That's what he has? Is that right? Pardon me? Oh, that on the other. You're right, minus 2y. My bad on that one. Now, I want to say one thing about that. I'm looking at this. Where this is 0 is the maximum value. Wait a second, no. Now, I'm sorry about that. This itself, I take it back. This could have a negative value, which would, with the negative in front of that, would make it positive. So you do have to do the derivative on this one. Y'all follow me on that, class? In other words, this, if it was just x squared plus y squared, we could set it equal to 0. This part right here allows for the negative value of y or x, and this would have a negative value with a minus sign, would make it larger than 0. Y'all follow me, class? Assuming, so that you would have to do a derivative, and that's the way it would be. Okay, I wanted to do that problem, and I want to mention one thing, and this is real important. Most of the problems that we have where there's some signal that's measurable, and you have the actual statistics of the signal, the x signal, known plus noise. Anytime you do that and you look for the most probable value, you're always going to look at the conditional probability of x given y. In other words, you observe y. And then on that side, you're going to get this kind of stuff that I showed you right here. But when you look at the most probable value, you don't even care about that. Just take a derivative of f of xy, all right, x given y, that's f of xy. And then you have to go ahead and set it equal to 0. My mistake was I didn't account for the possibility of x or y in that being equal or having negative values, because this is over all possible values of x and y. That's the reason you have to do it. Otherwise, we could have got away with what I showed you. All right, that's
just part A.
All right, what's the next one?
The next one is if the observed value of y is 3, find the best estimate of x.
Okay, well, if you look here, right here, that's the most probable value, right? So if the observed value of y is what?
It is y equals 3.
X should be minus 6, right? Do you agree with that? Is that right? Okay. What's the next part?
That's it for that question.
It's not that tricky, but you have to realize always, and this is a mistake you can make, down here, this doesn't matter if it's most probable. Now, for the actual statistics, then it matters, right? And we could get K for that one, but I want to mention, I had it over here. That integration is not a trivial one if you try to do it. And the reason is because you've got that product of 4xy. You're going to have to do one integral, then the next based on the other, and it'll take some time. All right. Next thing I want to do is go on to the next problem, but this is in section 3.3, or sorry, section 3-3.
3-3.
And this is more unconditional probability, I believe, right?
Yes.
I did these problems. Well, let me go through this. Sorry, the fireworks last night were a bit distracting. If you've got a dog, they don't necessarily enjoy that stuff. Go ahead.
All right, so 3-TAC 3.1. For each of the following joint probability density functions,
Oh, yeah.
state whether the random variables are statistically independent and find expected value, or EXY.
Yeah. What I want to do is bring up how you define statistical independence. That's the first thing. But give me the function here.
Okay, so for part A, f of x comma y
It's a joint density function.
equals kx over y.
For xy equal what?
And then x is greater than 0, less than or equal to 1, and y is greater than or equal to 1, less than or equal to 2.
All right, so they give us the actual parameters of where it exists. Now, I'm going to do something over here and just tell you this. This is important. This part is important. If something is statistically independent, you can always factor it into just a function of x and just a function of y. So if you have f of x comma y, you can get f of x of just x times f of y just y. You've got to be able to do that. Y'all hear me on that? If you can't factor them into separate functions, it can't be statistically independent. Y'all hear me on this? Now, if you look at this one, without doing anything to calculate k, can you see how you can get k, and then the function of x is just x, and the function of y is 1 over y? Y'all with me on that? That checks that box without doing anything to calculate k. Do y'all hear me on that? Oh, all right. Now, if you had something where you had like k times x to the y power, you can't do that. Y'all, I mean, I'm just trying to tell you, unless you can factor it into two separate, just a function of x and y, separated, I should say, separate into just a function of x, just a function of y, you can't do it. Now, I'm going to do one other thing on this one. How do we get k? Just to really drive home that point. You had to do this on the exam. You've had to do it a couple times for just one variable, and I think for joint variables, I gave you several problems with it too. But how are we going to get it? Yeah, we're going to say 1 is equal to, it would be a double integral of f of xy, and that's going to be k times x over y, right? And then it's going to be y, dx from 0 to 1, and dy goes from 1 to 2. We're going to calculate k. I don't know if he asked for k, but I think he does, somewhere in there. You agree with me, class? Everybody? Okay, so when you do it, what do you get? Well, I have 1 over here equal to, and I'll put the k out in front, and then I'm going to do the integral of x dx is x squared over 2 from 0 to 1 is 1/2. And then I have the integral, I should have put dy here. When I have the integral of 1 over y dy, that's natural log of y, and it goes from 1 to 2, or natural log here of 2. You all agree with this? Now, that means my k value, to make this a legal function, would have to be 2 over the natural log of 2. Is that right, Zach? Yeah. But you follow me. I'm just doing the simple integration. These are not tough integrals. What's the next part? They are statistically independent because I can separate them to just a function of x, just a function of y. Now, go ahead.
He wants to find the expected value of x times y.
We're going to get that in one second. I want to mention this one thing. One other thing about this. If you didn't see an easy way to factor this, like this is easily factored, how would we get just f of x if we had this joint density function? Anybody?
Take the integral with respect to y.
Integrate out What? Y. I mean, you'd integrate out x. You'd integrate this thing dx from where it exists, then you get f of y, right? We could do the same thing, only there we take this and integrate out y then, right? Now you have f of x, f of y. You put them here. If they're not equal to this, it is not statistically independent. Y'all follow me? We'll get into more of that in a bit. Now he wants the expected value of xy, right?
Yes.
Let's just do this as a class. So if I want the expected value of anything, in this case a function xy, the only thing I need to do, and it's a double integration, right? But I'm going to show you, you don't have to do it this way. All right. Now you put the function in here, which is x times y, and then you put the density, the probability density function, which is this. It's going to be k, which k is equal, I'll just leave it as k, it doesn't matter. K times x over y. Then you go dx dy. X goes from 0 to 1, y goes from 1 to 2. That's one way to do it. Do you all agree with that? And that will get you the right answer. The nice thing about that, the y's cancel, right? You get an x squared integration. But because these are statistically independent, it will be equal to the expected value of x times the expected value of y. You all follow me on that? Now that means you can just use f of x times x and do the integration with respect to x, and then take y times f of y, and you'll get the expected value of y. Do you all follow me? Because they are statistically independent. We can do it this way or that way. You'll get the same thing. But when I do it this way, one thing everybody sees is the y's cancel. So I'm going to just get rid of the y's. And now, when I go ahead and do this, I have k out in front. Then I have x squared integrated dx is x cubed over 3 from 0 to 1 is just going to be 1/3. Now I integrate dy, I get y from 1 to 2 is just 1. Do you all agree with that? If you get dy integrated, you get y evaluated from 2 to 1 is 2 minus 1 is just 1. Do you all follow me? All right, and that's k, and that would be the expected value of x, y. Since k is equal to 2 over log 2, and it's that divided by 3. So it's 2/3 divided by log 2. Is that what he has in there, Zach?
2/3 over that. Yes.
Over log 2.
Yeah.
Okay. Yeah. Is everybody with me on that? What else does he ask for that one?
Oh, that's it for part A.
Does he give you an actual number for this, or just leave it like that? It doesn't matter. We can.
Just leaves it like that.
You can get a number, right? Okay. So, part B, and I hope this helps when I'm doing this. I've been thinking about going through more theory. There's a lot of things you can expand on, types of functions that can be easily separable and stuff like this. But if you just see the problems worked, it all kind of is cleared up because I apply the theory to the problem, and I'll mention. Next problem, or part of that problem, part B.
Yeah, part B. So the new joint probability density function is k times x squared plus y squared.
Quantity?
Yes, k quantity x squared plus y squared. And that's x and y going from 0 to 1.
And 0 else, right?
Yes.
Okay, for that one, I want you to take a look, and I'm just going to mention something about it. Let me see if this works. That one out. A little house cleaning. That one, yeah, not so good. Okay, so that's a joint density function, right? Can you factor it into just a function of x and just a function of y? They're additive. If they're multiplied, if it was x squared, y squared, we could, right? Do you all follow me in this class? You can't easily get that, can you? Do you agree with me? We can get a value of k. Now, I'll tell you what. There might be a sleight of hand with the value of k on this one. But you can't, it's not an obvious thing where you can just break it into a function of x, function of y. So first I'm going to do this before I do anything is, how would we get k? All right, so I'm going to get k first for a legitimate function. All right, so if we put 1 is equal to k, I'll take that outside. I'm going to take the density function, and it's a double integral of x squared plus y squared dx dy. Here x goes 0 to 1, y goes 0 to 1. I get 1 equals, I'm just doing the integration, is going to be equal to k, right? Now, if I integrate this first integral, and I'll leave a second integral, when I do the dx integral, I get x squared dx is x cubed over 3 from 0 to 1 is 1/3. And then I get dx times y from 0 to 1 is just, y squared is just plus y squared. dy goes from 0 to 1. Here I'm just doing the first integration. Now I'm going to do the second, but it should be clear that there's no trick here. It's just a straight integration. So I have 1 is equal to k. Now when I do this integral, when I have 1/3 dy, I get y from 0 to 1 is just 1/3. And then when I have y squared dy, I get y cubed over 3 from 0 to 1 is just 1/3 as well. So that gives me a value of k is equal to 3/2. That makes it legit, right? Now for this one, I'm going to do the thing, and I'm going to get just f of x and then get just f of y. And we're going to multiply them and see if they're equal to this to prove the point. You all with me? So over here, now I'm going to go ahead and get f of x, which will be f of y, only with replacing x with y here. They have to be the same. And that's going to be equal to the integral from 0 to 1. K's coming out in front. And then I have x squared plus y squared dx. Do you all agree with that? Right?
Should be dy. It's f
Oh,
of
I'm
x.
sorry. Yeah. dy, my bad. I'm sorry. You're right. Apologize. With me, class? Go ahead and do that one. What do we get? We're going to get k, right? And here you're going to have quantity x squared. We actually did that over there. And then when we integrate y, we get y cubed over 3 from 0 to 1 is plus 1/3. So that's simply 3/2, and it's going to be x squared plus 1/3. Now it'll be the same thing for y because of arguments of symmetry if you want them. X squared plus y squared have the same weights in front of them. If you do the integral with respect to x to get f of y, you're going to get the same exact thing only with a variable change. So that's equal to 3/2, and this is going to be y squared plus 1/3. Do you all agree with that? Now, I can go further, but take a look at this. The only way for this to be statistically independent is if I can do f of x, f of y equals this. If I put this down over here, you'll see it. I get k times x squared plus y squared equal to, and then here I have 3/2 times x squared, or x squared plus 1/3 times 3/2, and it's y squared plus 1/3. Now the way you can do this simply is to see if there's a k out in front, but I wouldn't even worry about this. The value of k we got was 3/2. I'm just going to put it here. Forget the 3/2. How many? The easy way to figure this out is see if it's equal for all values of x and y. So pick x, y equals 0. Do you all hear me on this? If x, y equals 0, this is 0, isn't it? Correct? Is it 0 on that side? If that's 0 and that's 0, you still have a constant multiplied through. It's unequal, in other words. You all follow me? So I can say, based on this, this is not statistically independent. It's statistically, that one is dependent on the other. I saw it up here too. I couldn't easily factor this, right? I can't get just a function of x and just a function of y because they're additive. If it was x squared times y squared, then they would be statistically independent. But y'all follow me the reason behind it. Now on a quiz on Friday, maybe I can get your attention now, I could ask something if something was statistically independent. Let me just be straight with you. I'm going to ask something if things are statistically independent. You can do it either way, but if you play with this stuff a little bit, you can see that without doing anything further. Can you all see me? Sometimes it gets a little tricky. There can be things where the value of k determines if it's independent or not. And that's when k weights these things. And I'm just going to say there's a lot of different things that can happen that can confuse you. Did he ask for more on that one?
He also wants the expected value of x, y.
All right, so let me do that part over here. These are not statistically independent, so I can't just get f of x multiplied by x and then integrate it, and times f of y times y and integrate it. I can't do it because they're dependent on each other. You with me, class? So now I come over here and I'm going to say, well, what is the expected value? And I could ask something like this on the quiz. I could ask something like this on the quiz. Underline. I mean, if you're not in class and you don't watch these things, I can't help you. But if you come, you get tidbits of useful information. All right, how do we get this, guys? It's a double integral, you're right. K was 3/2, wasn't it? So I'll put the 3/2 out in front. And now I know the integration is from 0 to 1. And now I take x times y times this stuff. So it's going to be x times y, and it's going to be x squared plus y squared, right? dx dy. Do you all agree with this? Now, you can see that I have to do the integrations twice to get this right answer. But there's something else you can see. You see the level of symmetry there? I'll just break it out and do it. But when we get the first integration, we have the second one by default. I'll let the 3/2 be here. And now I'm going to break this up as x squared dx dy. So it's going to be an integration of x times y times x squared dx dy, 0 to 1, 0 to 1. Try to get a better marker. And then this part, which is going to be plus, and here it's a double integral from 0 to 1, 0 to 1. Now it's y squared. I'll just put y cubed here, and it's going to be dx dy. Y'all follow me? And I'm breaking it out so you can see. I'm not going to try to fly through this one. Everybody okay with that? Go ahead and do it. What do you get? 3/2 is out in front, right? For this one, I get, and you're going to see that both of these are going to be the same. I get x cubed dy, and I have to integrate first dx, so it's going to be x to the 4th over 4. Do you agree with this? Times y, and then when we integrate y from 0 to 1, it's just 1. So here we get 1/4. What do you think we're going to get over there? 1/4. Do you agree?
Well, wouldn't dy of y be 1/2?
I'm sorry, what?
If you're integrating y, wouldn't that go to y
Oh,
squared
I'm
over
sorry.
2?
Gosh, I'm sorry about this. Yeah, I am sorry. You're right. I'm getting careless on this. This integration is going to be an x to the 4th over 4. Then y dy would be y squared over 2. So it's actually going to be 1/8. My bad on that one. But this one will be 1/8. I'm sorry about that. You're absolutely right. You agree with this, class? So here, that's really going to be 3/8, isn't it, class? You agree with me? Is that the right answer, Zach? All right. I'm just showing you. You'd have to do the integration. I'm sorry I'm making mistakes. Anyway, that's what I got. What's the next part?
That was it for part B.
All right,
And part C is a
do
different
it.
function.
hold on. Go ahead.
Okay, so for part C, you have f of x comma y is equal to k quantity xy plus 2x plus 3y plus 6. And then x and y are going from 0 to 1.
Okay, that's a good problem. So, and it's 0 else, right?
Yes.
How do you figure out if they're statistically independent? Now remember, the key is what? You have to be able to factor just the function of, or separate just the function of x times just the function of y. I look at that, it looks tempting. Maybe I can figure out something, but really, whenever you see these pluses separating, almost guaranteed it's impossible. Almost. How would you do it? What does he ask for now?
It's the same thing as the other questions.
Okay.
Find if they're statistically independent and then find expected value
How
of
about
x,
we
y.
get the value of k first, then we're going to get f of x, then we're going to get f of y, okay? With me on that? How do we get the value of k? We'll do it over here.
Integrate.
All right. Okay, so I'm going to say 1 will be equal to a double integral of, and I'll put the k out in front, of the quantity xy plus 2x plus 3y, right, plus 6 dx dy, and it goes from 0 to 1 in both cases. I think everybody agrees with that. Some of this stuff may get boring, but please work with me on this. There might be some subtleties. So just doing it, I think I can say 1 equals k. When we do the first integration with respect to x, we get x squared over 2 from 0 to 1. It's just 1/2, right? When we do the second one, y dy, we get y squared over 2 from 0 to 1. It's just going to, so it's 1/4 for the first part. Does everybody agree with that? All right, next part. We have 2x dx is x squared over 2 times 2, or just x squared from 0 to 1 is 1, right? And then we do dy from 0 to 1, we just get 1. So it's just 1 there. I hope you all follow me. This is kind of boring, but just work with me on this one. What about the next one? What is that going to be? 3y integrated dx is 3yx, where x goes 0 to 1 is just 3y. Integrate that, right? And what do you get? You get 3y squared over 2,
3 halves.
or 3/2, right? Do you all agree with that? Finally, the last one, 6 dx. Integrate dx from 0 to 1. You get x evaluated from 0 to 1 is 1. Y dy integrated is just y from 0 to 1 is 1. So that's plus 6. You all agree with this? So what's k going to be? Let's see. 1 is equal to k, and this is going to be, we get a common denominator of 4, right? So you get 1 plus 4 plus 6 plus, what is that, 24. Correct, class? And what's that going to be? That's, this is 10s, 34, 35, so k is 1/35, it looks like, if I did my math right. Is that right, Si?
It's 4/35.
What?
4.
Did I mess up something? For k?
You forgot to put your denominator 4.
35/4, so it's 4/35. My bad. So k is equal to 4/35. I'm sorry about that. Okay, what's the next part?
Is to find out if they're statistically independent. But we already said
Did you have a
that.
question? Anybody have a question about this? It's just a straightforward integration. Set it equal to 1 and solve for k. That's the only thing I'm doing here. I'm being a bit sloppy, and I'm sorry. I'm trying to be more on point here. Go ahead.
Are we skipping the statistically independent since you said there's plus
Well, we can, how would you, let me ask you this. If it was a quiz, and I asked you if it was this statistically independent, and I'm asking you to prove it is or isn't, how would you do it?
Get f(x), f(x).
Technically, we need f of x and f of y, and we multiply them. If they're unequal to that thing, right, then they're not statistically independent. Y'all with me? we might as well just do this because this is the kind of problem that I guess you have to be careful that you don't make errors like I've been making. Okay. All right, so how do I get, just looking at this, how do I get fx of x? I would take that guy, right? It would be k, and then I'm going to do the integral from 0 to 1. It would be a dy integral of xy plus 2x plus 3y plus 6 here, and I'm going to integrate dy, correct? What is that going to end up being? That's k. When I integrate dy here, I get y squared over 2 times x. Evaluated y from 0 to 1 is x over a half, right? So work with me, make sure I don't make a mistake. Then I integrate this dy is just plus 2x, right? Then I have 3y dy, that's 3y squared over 2 from 0 to 1 is just going to be plus 3 halves. Does everybody agree with that? Finally, the last one is just 6, isn't it? Plus 6. So this, let's see, I'm going to have, this is k here, and then I have x over 2 plus 2x, and that's going to be 5 halves x plus, and then I have, what, 15 halves here, is that right? 6,
That's correct.
15 halves. So that is f of x, and how do you get f of y? Of y, same deal, right, from 0 to 1 of quantity xy plus 2x plus 3y plus 6 here. And this is going to be just dx integration. And it's got a k in front, so it's k times, might as well do them. So xy dx is x squared over 2 from times y, so it's going to be y over 2. Plus, then when you do x dx, 2x dx is x squared over 2 times 2 is just x squared from 0 to 1 is plus 1. And then when we do 3y dx, you just end up getting 3y. And then 6 dx is just going to be 6, right? So here, this one, f of y, I'll get out of your way. Let's see if we can get this together. I got k, but I think you can all see it by now. That's 7. And then I have 3y over 1. So 6, 7 halves y. And now, if I take this right there times that right here, and I'll just do it right here. Let me, I'll just show you what I'm doing. I'm going to put this down, and you'll see exactly what I'm doing and why I'm doing it. I'm just going to test. I usually test at xy equals 0. So test this function. K itself was 4/35, so 4 over 35 here. Now I'm going to rewrite this. And xy plus 2x plus 3y plus 6. Is that equal to, at 0, this stuff? So I have k, which is 4 over 35. And it's going to be times 7 halves y plus 7. And then the other one has got a k, so it's k squared over here. And it's 5 halves x plus 15 halves. So, I mean, the way I check it, let xy equal 0, see if both sides are equal. Now that's not an absolute proof, but if it doesn't equal at that point, then it automatically means it can't be statistically independent. So out of curiosity, if xy is 0 on this side, I would have simply 4 over 35 times 6, right? You agree with me there? On this side, if xy is 0, I have 4 over 35 squared, and then I have 7 times, it'd be 7 times 15 over 2. Let's see, I can get rid of one of those 4 over 35s, a constant k. Do you all agree with this? So I'm just going to erase this one, trying to make my life a little easier. And let's see, I'll try to simplify this. So I have 4 and 2 is just going to, divided by 2 is just going to bring out a 2. And then I have 2 times 7 is 14. 14 times 15 over 35.
It equals 6.
It does.
It does.
That means they're statistically independent, at least at that point. Is it statistically independent?
He doesn't actually say if it is or isn't.
I mean, that's only at one point, but to factor it, you should be able to factor this thing into two functions. So what would be the factoring of that? Let's see. We got it right there. It's going to be 7 halves y plus 7 times 5 halves x plus 15 over 2 times that 4 over 35 squared. I didn't see that factoring, but that's how, he must say, doesn't he ask if they're statistically independent?
He does.
He doesn't,
He just doesn't answer it. I don't know why.
they have to be. I mean, if that is true,
It equals 6.
then they have to be. And what else does he ask?
He wants you to find the expected value of xy.
Okay, if they're statistically independent, we have f of x right there, and we have f of y right there, right? So how do you get, if they're statistically independent, then we can do this, which is kind of nice. I don't remember that result. But obviously, that's just a function of x. That's just a function of y. When you multiply them, you're going to get that. I didn't see that factoring up. Does he factor that at all or not?
No.
All right, well, I'm not sure about that. All right. Getting back to this thing now, the expected value of x, y, if they are statistically independent, that's simply the expected value of x times the expected value of y. Do you all agree with this? All right, so what is the expected value of x? It's equal to what? The integral from 0 to 1, that's where it exists, of just f of x, right? And f of x is going to be k, right? And then it's times 5 halves x plus, you know, this is kind of an irritating problem. It's long. And it's going to be times x dx. We'll get to this value. But you all agree that would be the expected value of x? I take f of x times x, and I get it. And what's the expected value of y? Well, the k can come out in front. It's an integral of y from 0 to 1. And here, f of y is 7 halves y plus 7. dy, right? By the way, Zach, does he shows this integral in there?
No, he doesn't.
Take a look at this. He does the whole thing right here. He multiplies it out. Do me a favor, just can somebody do this fairly quickly? Let's see. We could do it. This is going to be.
The whole thing is equal to 88 over 315.
What is?
The whole thing.
I know, but when you, I wanted to. So this is going to be equal to k, and then it's times 5/2 here. And then you're going to have x squared dx is just going to be 1/2, comes out there, plus, and it's going to be 15. Oh, sorry. Let me do it this way. All right, we got x squared dx is x cubed over 3 times 5/2, so it's k. So it's going to be 5/2 times 1/3 here. And then you're going to have x times 15/2 is going to be x squared over 2. So it's going to be plus 15. What is it?
55 over 12.
For this whole thing up top? 55 over 12. What about the bottom one? Can you do that? Y squared.
I got 8 over 15 for one of them.
8 over 15? All right, if you multiply this times that, what do you get? So the expected value of x, y, if they are statistically independent, is going to be 55 times 8 over 12 times 15.
Times 435.
Pardon me?
Times k. Yeah.
It's k squared though, isn't it? Is it? This is k and this is k, so it should be k squared, right?
Yeah.
Yeah. It appears twice k, so if we're multiplying, it's going to be this times k squared, and k is what, 4 over 35? And it's squared. What do you get for this? 16 times 8 times 55 over 12 times 15 times 35. God, that's a big number. I don't know.
For that, you get 352 over. What do you only have 1k?
Yeah. But remember, when we have the joint density functions, we're going to get a k remaining in both, right? But if you do the integration, it should come out the same. What is this value right here?
That's 352 over 1125.
And what does he have?
Or 11,205. Sorry.
What is it?
Or
Isn't it 11,000?
Yeah, 11,025.
025?
Yes.
All right. Just give me the decimal number. Hold on for 1 second.
0.058.
And what does he have?
He has just 88 over 315. He
Yeah.
just does k times
Over 315?
That's what I got when I did the whole thing.
All right. And what do you get for that in terms of?
k squared though. He does 1k. That's what he gets to that.
Yeah.
Well, but he does the joint density, right?
Yeah.
Okay. What did you get for this one?
That decimal was 0.279. Wait, no, it's. Wait, I'm sorry.
Pardon me?
Yeah, it's different.
Yes, sir.
Yeah, there's an error there. Expected value of y.
What's that?
That should be 14 over 3.
Yeah,
This should be what?
14 over 3.
Sorry. 14 over 3? Over 3?
Over 3, yeah.
All right.
Times k.
Times k. All right. So if you just do, and I'm very curious about this now, forget that. So I'm going to take it, it's going to be k squared, so that's going to be 4 over 35 squared. That's k squared, because k appears in both f of x and f of y, right? Then it's 14 over 3. I want to see if this works. 14 over 3, and it's times 55 over 12. Tell me what you get there.
That's correct. That's the 88 over 215.
Thank you. 88 over 315. I'm sorry, math is, today I've been slipping. All right, but when I tested it at 0 and they agreed, you follow me? When x, y equals 0, that's not a general proof that in fact they're equal everywhere. But if they're equal at 0, when x, y is 0, almost always. If they're not equal, I should say, if they're not equal, then I know that they're not statistically independent. Yeah.
If on an exam or a quiz we tested with 0 and they're both equal, can we just say that they're statistically independent? Or?
The idea is this: if they're not equal, they're not statistically independent. That if it's zero, it still might be. I don't want to lead you astray in that one, but that's the way I learned this a long time ago. Instead of doing long, elegant proofs to figure out things, if you can just see quickly at one point, if you can estimate if one side is equal to the other at one point, if they're not, then the whole thing falls apart, so they're not statistically independent. In this case, they were, and they are statistically independent. And that is the factors that we'd get for that. Is there another part to that problem?
There's no more parts of that problem.
There is?
There's
Or
not.
No? What's the next problem? I'll get to covariance if I don't know if I'll have time, but I wanted to do a couple more of these.
Yeah, because the next problem tells you that it's statistically independent.
Okay, hold on for 1 second. Let me get this out of here. Just bear with me. Go ahead.
All right, so 3-TAC 3.2, let x and y be statistically independent random variables.
Okay.
And then let w equal g of x
Okay.
and v equal h of y.
H of y. All right.
And then b, any transformations with continuous derivatives on x and y. And then show that w and v are also statistically independent.
He just wants to let you know that if you have, and the way to prove it is you can say that that x is really, you might say g minus 1 of w. It's just the inverse function. And you can say that y is equal to h minus 1 of v. In other words, that's x and y. Now, then you can go, do you remember if we had, I think this is in chapter 2 of the book, when we talked about if you get f of y given x times do y'all remember this when we did this? I'm running out of time here, but how many do? We actually did this. This is conditional probability. What I actually did was show you something like f of y given x is equal to f of x comma y over f of x of x. Do you remember that? So if you rearrange those things, I can get this over here. And then if I do it for f of x given y, I still have this, only this becomes f of y. If you solve for this and then replace it, you're going to get this. All right, so now he's saying we know the statistics of f of x, they're independent, and f of y. So what he's going to do is say, if I want, I'm trying to do this the way. If I want the statistics of this, all right, and I have the statistics of this, I can use this actual law to do it. Does he show this in the book? Does he go through the proof on this? I mean, in the solutions? Let me take one quick. He's going to do that integration, or he's going to set it up at least. Okay, he's going to do basically that, only here's what he's going to end up doing. Well, I'm out of time. Let me get this in your book, show you where it is, because I know I'm going to have to take a derivative of these functions to do this, and this is going to get a little bit confusing, but here in the book, on page 60, if you write this down, in equation 2-5, he'll have, if you have, and I'll write this up here. So if you have f of x right here times dx, that's equal to f of y times dy. Forget about, well, we'll do the derivatives in a second. So if I wanted to know f of y of y and I had x, for instance, it would be f of x divided by, and then it would be dy dx. Now, I hope you can follow me on that one. You with me on this, class? And this goes back to the prior stuff. So if we take a look at the problem, and we just take a look at the first part, I have w is g of x, right? And I have the statistics for x, right? So if I want the statistics for w, if I want f of w right here, then what I can do is take this f of x, or g of x, right? And then down here, I would take a derivative of this with respect to x. So I take a derivative of w with respect to x. And this is going to be f of w, and you replace here w with this value in here. So in his book, or in the solutions that he has there, if you look at this, he's going to actually do this, right? Yeah, he just actually, you don't have to worry about that. I'll post some things about this. The way he does it, he spends a lot of time doing something where he gets just a function of, if you look at this, this is just a function of x, okay? On this side, that's f of w. And then over here, when he'll do it for this f of y, this is only a function of x. This will be only a function of y. When you multiply them together, you can separate them and prove that, in fact, w and v are statistically independent. But here's the real way. Anytime you have any function, I mean, anything that's a function of a variable that's statistically independent of the other, this can never become statistically dependent on the other variable if they tell you that. Regardless of the functional form, it's impossible. I wanted to get to covariance. I'm not going to have time today. But I did want to say just one thing to give you a heads up. Now, we're talking about conditional probability and how to go about solving problems. You're more worried, probably concerned about how or what the quiz would look like. It's going to look like stuff out of section 3-2 and 3-3. Okay, I didn't get through all the problems, but they're template kind of problems. You with me on this, class? Now, something I just want to mention before I let you guys go. This is in section 3-4 in the book, and it talks about covariance. This is really important. So, if you take the expected value of x minus the mean of x times y minus the mean of y, this is really a very, very important thing. This right here, now we've got rid of the means, will tell you how much alike x is with respect to y. And you have to get rid of the actual mean values, or this will lose meaning. But it'll tell you how much one tracks the other. So to do this, if you think about it, technically that's going to be equal to a double integral, and it would be of x minus x bar, y minus y bar, and then you're going to have f of x comma y, and you're going to have dx dy over the range where it exists. Can you all follow me on this? I'm just putting down literally the definition of expected value, but I've subtracted the mean. Now, if it was just the expected value here of x minus x bar, that alone, well, that would be 0. If you subtract off the expected value and but for this, we're going to get something called the covariance matrix. Now, I'm just going to mention this. You're going to have xy, and then you're going to have this term, xy. Then you're going to have x bar, xy bar, and then plus xy bar. And when you break this thing out, you're going to get 3 terms on top, and divided by one term on the bottom, and it will be equal to covariance. I don't have time for this, but I'm going to do this next time. I'm going to ask you to do a little reading in section 3-4. So at least when I come in and I start, you'll be somewhat prepared or anticipating what I'm going to talk about. Sorry for the mistakes today, guys. All right, Friday, everybody understands. Homework section 3-2, 3-3. And know how to find if it's independent or not.